Hello, algebra students, Mr. Lawrence here. And somebody asked me, one of your classmates asked me to make a video about 7-4. And so this is what this is. It's to help you get ready for the test. Now, I want to point out that, remember, we've learned that when you multiply like bases, you add the exponents. Like, for example, if you have x squared times x to the fifth, that's the same as x to the 7th power, right? 2 plus 5 is 7. Okay. When you divide like bases, whoa, I have a typo there, don't I? Yeah, when you divide like bases, you don't subtract the bases, you subtract the exponents. So sorry about that, ladies and gentlemen. All right, let me fix that right away. Subtract the exponents, right? So if we had, say, x to the 12th divided by x to the 4th, that would be x to the 8th, because 12 minus 4 is 8. And if we get a negative number, well, negative exponents means we have to take the reciprocal of the base. So if I have x to the negative third, that would be 1 over x cubed, right? Or if I had 2 over x to the negative fifth, well, I would take the reciprocal of the base, and that would move that x to the negative fifth to the numerator, and it would become 2x to the fifth. Okay, bouncing back up here, if I had x to the third divided by x to the ninth, that would equal x to the negative sixth, and then I would have 1 over x to the sixth. And there you go. Okay, and the last thing I want to review before we actually do some problems is when a power is raised to a power, you multiply the powers. So if I have like x to the 7th raised to the 5th power, well, that's the same as x to the 35th power, right? Oh, that doesn't look like a 5. Hold on one second here. All right, so 35th power. So, because there'd be 5 of these, right? So there'd be an x to the 7th, x to the 7th, x to the 7th, x to the 7th, and x to the 7th. And that would be like 35 x's being multiplied together. Okay, so let's apply all those to some sample problems. Problem number 1, very similar to what we did in class on Wednesday. I'm going to simplify inside as much as possible. Then I'll deal with the negative exponent. So, as I simplify in the quantity, I believe 6 divided by 3 is 2. N squared divided by n is going to be n to the first, right? And then I've got a negative 3, which tells me to take the reciprocal of the base. So now I'm going to have 1 over 2 to the power of n to the third power. And cubing 1, I get 1. Cubing 2, I get 8. And cubing n, I get n cubed. And there you go. Okay? Now, sometimes we did problems like number 2 here. And again, we're just going to simplify. This is where I like to get my highlighters out. And so I'm going to highlight the terms with the negative exponents. And that's going to cause those terms to move. Since they have negative exponents, they're going to move from the numerator to the denominator, or from the denominator to the numerator. So first of all, I'm going to have 12 divided by 4 is 3. And that's in the numerator, yes? Now this a to the first is going to drop down to the denominator. I'm going to have a to the fifth times a to the first. Well, that would be a to the sixth. Okay? If I have b to the sixth, this b to the first is going to move to the numerator, and so there's going to be b to the sixth times b to the first, which is b to the seventh. And then here, the c to the negative third is going to drop to the denominator, and I'm going to have c to the fifth times c to the third, or c to the eighth. Now, some of you don't want to do it that way, and that's okay. There's different ways to do this. Some of you like to do it the subtraction method, right? Like we talked about in the opening. So, first of all, you all agree we're going to get 3 there. That's no problem. Now, we're going to have a to the negative first divided by a to the fifth. Subtracting the exponents will get me a to the negative sixth. And since it's a negative exponent, I have to take the reciprocal, and that'll force it to be 1 over a to the sixth. Where's my a to the sixth? Oh, it's in the denominator. All right, I'll put an a to the sixth in my denominator. Okay, on this one, I'm going to have b to the sixth divided by b to the negative first. If you want to subtract the exponents, you're going to go 6 minus negative 1. Well, minus negative 1 means plus 1, so that's going to be b to the 7th power. And look, it's in the numerator, b to the 7th. And you notice I'm getting the same answer in the green as I was in the black. So it's totally cool to do it this way. Okay, finally, this one's going to behave very much like the a terms. It's going to be c to the negative third divided by c to the fifth. Subtracting the exponents gets me c to the negative eighth. That's going to cause me to take the reciprocal. I'm going to have a c to the eighth in the denominator. Yeah, same exact answer. Both ways are great. Okay, so this one here, I want you to write the answer in scientific notation. Well, I'm going to do it just like the other problems. Like, for example, 10 to the 13th divided by 10 to the 7th is going to be 10 to the 6th. Okay, so I'm going to have a 10 to the 6th. Now, 52 divided by 13, I think, is 4. So 5 and 2/10 divided by 1 and 3/10, I think, is also 4. Doesn't it look like 52 divided by 13? The decimal points are in the same place. So we're going to get 4 times 10 to the 6th. Now, if you're not sure, you want to do it the long way, well, you can go, the long division route, right? And then you can multiply by 10 here and here, and sure enough, it's going to go in 4 times, okay? All right, now, remember that with the scientific notation, if that lead coefficient, that 4, had not been between 1 and 10, then I would have had to have manipulated it, right? I'd have to like multiply or divide here and then do the inverse operation there. Okay. All right. Now, maybe numbers 4 and 5 are giving some of you trouble because you don't like the fractions. Well, let's see what we can do with this. We've got division here, so we're going to subtract exponents, right? So I'm going to have m to the 7 halves divided by m squared. 7 halves is the same as 3 1/2. And 3 1/2 minus 2 is going to give me m to the 1 1/2. Now, it's really not considered good form to leave that as an improper or as a mixed number, so I'm going to convert it back to an improper fraction. 2 times 1 plus 2 is 3, and it's divided by 2. So I've got m to the 3 halves. Now, n to the 5th over n squared, that should be pretty easy at this point. It'll just be n cubed. And there you go. There is a simplified version of number 4. Okay, number 5, same thing. You may want to just turn this into 2 1/4 right off the bat. Okay, so I'm going to have x to the 2 1/4 divided by x squared. Well, isn't that going to be x to the 1/4 power? And then my y's are going to be y to the 5/7 divided by y squared. Well, I've got to subtract those exponents. Well, let me see here. 2 minus 5/7. And by the way, if you have trouble with this, come see me. It is so simple. I'll straighten you out in 2 seconds. We're going to not have 2 holes. We're only going to have 1 hole. And what makes this a hole? Well, it would be 4/7. Okay? Now, I don't like the mixed number, so I'm going to go y, and I'm going to change it to the, well, that's going to be -4. Oh, I'm sorry. That's 2 minus 5/7. I'm supposed to be doing 5 minus 5/7 minus 2. So that's just going to be negative 1 4/7. And now I'm going to turn it into an improper fraction. So I'm going to get 7 times 4 is 11 sevenths. It's negative. All right. So right now my answer looks like this. I've got x to the 1/4 and then y to the negative 11 sevenths. I'm going to get it so I only have positive exponents. And then y is going to equal negative 11. Oh, positive 11 sevenths because I moved it to the denominator. And there you go. All right, one more example. So here I have power raised to a power. So I'm going to take z to the 2/3 and I'm going to cube it, right? Which means I'm going to multiply 2/3 times 3/1. Those will cancel, leaving me with 2. So the numerator is going to become z squared. Now the denominator is just 5 cubed. Well, 5 times 5 is 25, times 5 is 125. And there you go. Hopefully this helped, okay? If not, let me know, and I can always make another video over the weekend or something. But I'm just trying to help you ladies and gentlemen out. Okay, that's it for tonight. Have a good night, everybody.